Given a binary search tree, create a linked list of all the nodes at each depth. So this is the binary search tree. The main property of binary search tree is left side node will be less than the root and right side node will be greater than the root. And the depth will be calculated as, for example, the depth of this one will be calculated as number of edges between the current node and the root node. So number of edges is 1, so it is at the depth 1, and this one is at the depth 0, and this at the depth 2. So here I have to create a linked list with the nodes at each depth. So initially 10 and 8 and 12, because those are at the depth 1, and now 6, 9 and 11 has to be created. So here what I'm going to do is I'm going to store the value 10, and now this is a queue for suppose, and now my queue size is 1. So whatever is there to the left and right of it, I'm going to store that in the queue, so which is 8 and 12. And I'm going to, because I'm done with the number 10, so I'm going to create a temporary node 0. So 0's next will be 10, and now this is, so I'm just going to add to the 10. I'm going to add 10 to the next of 0, so 10 will be stored and 10 is removed. Now the queue size has become 0, and this shows that if the queue size is 0, that shows that that is at the end of the depth of 0. And now whatever is there in the queue size, I'm going to reassign it, so which is 2. Now 0 and 10 are formed, so this is at the first depth, because I'm going to consider it from here, I'm not going to consider the 0. And here 8 and 12 are there. So initially 8, because I have taken 8, 6 and 9 can be added to the end of the list, 6 and 9, and the size has decremented to 1. Now 8 is removed from the list, and now 12, because 12 is popped out, 12 is not there in the list, so the size has become 0, and it is added to the next of the 8, which is 8's next is 12, and whatever is there here, I'm going to add that one to the queue. And finally my queue size has become 3, because 6, 9 and 11 are there. So here also, so 0's next, 8 and 12 will be stored, and here also 0's next is waiting, and 0, I'm at the node 6, so 6 will be added, and the value is decremented, 6 is popped out, and it is going to check whether left and right are there for the 6. Because it is not there, I'm not going to add. And now 9 is popped out, the value is decremented, and 9 is added. Now 11, value is decremented, now 11 is added, and the size has become 0, queue has become empty. I'm going to stop here. So at the end, I'm going to have 10, 8 and 12, and 6, 9 and 11. So here I'm going to store in a list, so 10, so which is the first depth of the node, 0, and then 8, and then 6 are stored like this. So 10's next is nothing, 8's next is 12, 6 next is 9 and 11. So I'm going to, so with this list I'm going to access through all the depths. So how I can do that one is, so if root is null, just return null. I'm going to create a queue. So initially to the queue I'm going to add the root. So initially to the queue 10 is there, 10 is added. I'm going to store the list, create the list for storing the nodes at each depth, initial nodes at the each depth. The size is queue.size. I'm going to create a dummy variable and the previous variable. While queue is not empty, so initially 10 is there, 10 is not empty. The previous dot next, so 0's next will be 10. So 0's next will be 10 will be added, and this has become my previous now. If new node dot left is not equal to null, then 8 will be added. Then right is also not equal to null, and then 12 will be added. If size is 0, so here I have to make size minus minus. initially size is 1, now the size has become 0. Yes, size has become 0, and I'm going to reassign the size. So what is the size now? Because 10 is removed, size has become 2. List dot add of dummy dot next. So in my dummy 0 is there, dummy's next is 10, so 10 will be added. Now previous has become dummy again, so again 0 will be added. So likewise we can form a list which is going to store the depths of the nodes, the initial nodes at each depth. So 10, 8 and 9 will be stored. When I access 10, the whole list can be accessed. When I have 8, the whole list can be accessed. When I have 6, the whole list can be accessed.